Hello, dear students. Today I'm going to speak about measurements in chemistry. This chapter is so important that I will take more time explaining you everything because we are going to use this during all the class. First of all, how to read a scale. Look at this. This is a ruler. Every big line represents 1 centimeter. But between, for example, 0 and 1, you have 10 lines. How much is every line? Well, if you divide 1 centimeter by the 10 lines, you will observe that every small line represents 0.1 centimeters. If you do any measurement using this ruler, you will give, let me use here, you can say, for example, here, if you are here, for example, you can say that the length of the object that you will measure is 5.5 centimeters. This is what we call certain, because it's what you can measure. But let's continue. Now I'm going to speak another important thing. For example, this rectangle is for sure 3.1. This is certain. But what happened? There is a little more than 3.1. And then you have to estimate how much is the part that you're going to estimate. Well, in this case, it's between 3.1 and 3.2, and then I will say that is 3.51. Well, this phi is what we call the estimated part of your measurement. Estimated. And then, when you report any measurement using this ruler, you're supposed to give 2 decimals in your answer. If you don't, you are not doing the measurement in a correct way. Okay? Then this number has 3 significant figures. Every time I ask you to measure something using a scale that can be a ruler, but can be also the scale of a thermometer or whatever, you have to give 2 decimals in your answer. Remember, this part of the measurement is certain, and the last digit is always estimated by the person that is doing the measurement. That's why if other student makes the measurement, maybe we'll report 3.14 because this digit is estimated. Let's see in this example. You're sure that your measurement is the measurement of this bar is 3.0. But as you have to estimate an extra digit, your answer will be 3.00. Remember, if you can measure until the 10th, you have to estimate the 100. Here you have two examples, two more examples. Here you can see that even though we are talking about the same object, the answer of the measurement will be different. Here you can estimate between 3 and 4, and then you are certain that your measurement is 3. Then what you're going to estimate? Well, here I can say, for example, 3.2. And this part of the measurement is the one that you are estimating. But the same object, look, is the same object here. Using this scale, you can be you can be certain that, or sure that, your measurement is 3.123. For sure, it's 3.3. But it's a little more, and then you're going to estimate, for example, a 5. Then using this instrument, your measurement will be 3.35. By using this one, it can be, well, I say 3.2, but better we can say 3.3 because it's almost, look, here would be more or less 3.5, then you can say it's 3.3. For sure, you're sure that the length of this object is 3 centimeters, and you estimate the 0.3. In this case, you are sure about 3.3, and you estimate the number 5. And this depends on the instrument you are using. That's why the accuracy of a measurement depends on the smallest number that you can measure. And always you will estimate an extra digit. All right? Look at this. Here we are in front of a thermometer, but it's the same. You will treat this the same way. Well, here is bigger in such a way that you can see. Between 30 and 40, you have 10 Celsius degree. As you have 10 lines in between, you divide 10 Celsius degree by 10 lines, and you will see that every line is 1 Celsius degree. Then you will be sure that the temperature here is 3.8. Sorry, 38. But you have to estimate an extra digit, as in this case is sharp on the 8. Then you will estimate that the 0. But if you use, look, it's the same temperature, but in this case, the scale has only between the 10 Celsius degree, you have only one line, then you will divide by 2. Every line represents 5 Celsius degree. So the temperature here for sure is 35. But it's a little more, and you will estimate this. Then it's 3 degrees, extra 3 degrees, then you add, and then your answer will be 38. The estimation is here in this in the unit, in this case. In this case, is in the decimal part. Then, even though it is the same temperature, the reading, the answer is different because of the scale that you are using. look at this. You're here measuring the weight. In this case, you are sure about the weight of the object is 400 grams. But also, you have here 10 grams more. And here you can see that you have 2 grams more. But it's something else. It's something else. You can see that is 0.5 more grams. If you add everything, you will see that the answer is 112.5 grams. But is this your answer? No. You have to estimate an extra digit. Well, in this case, it's sharp on 0.5, then I will estimate the 0. And this is your answer. You have to estimate always the last digit. Well, when you are multiplying, and pay attention to this because you're going to have, during all this class, you will have a lot of multiplication, addition, and subtraction, and division. So you have to apply the rule for significant figures. Look at this. You have two factors. This factor has 3 significant figures. And this factor has 2. Of course, you know that these numbers come from a measurement, and this measurement depends on the accuracy of the instrument. The accuracy of the instrument is giving you here 2 significant figures. Then in your answer, even though you use your calculator, and this is a number that is given by the calculator, you cannot report this big number. You have to report only 2 significant figures that correspond to the factor with less significant figures. Then you will skip this number. As this number that you're going to skip is higher or is 5 or higher than 5, you will round up until 2 significant figures, and your answer is 13. This is the number that you have to report, and this number has 2 significant figures. Remember, in multiplication and division, you have to report in your answer the same number of significant figures as the number, the factor, for example, in this case, with less significant figures. Well, in addition and subtraction. Well, I can explain you a little different things, but the best way is setting the operation this way. Then, sorry, let me erase here. The numbers that you have to use are 6.8 and 11.934. According with this, your answer will be 18,734. Well, the practical rule in this case is to make a line by the number with least decimals. And then your answer will be this. As the first number that you're going to skip is lower than 5, you don't have to add anything else. Then the answer of this addition is 18.7. If you do this way, you will find the answer in a correct way. The same thing happened in subtraction. Let's speak a little bit about significant figures, the rules that are going to explain when a number is significant or not in a number. Well, the zeros to the left of the first number different from 0 are non-significant. All the numbers that are different from 0 for sure are significant. 3 and 4 are different from 0, they are significant. Oh, these two zeros after the 4 are also considered significant in this case because you have before a decimal point. Then zeros, when you have a decimal point, the zeros are at the end, the trailing zeros at the end are significant in this case. But pay attention to this. Look at this. 10 and 10 point, even though it's the same number, the accuracy of the measurement that you use in order to determine these two numbers are different. So the 10 point has two significant figures, while the 10 without the dot has only one significant zero, because this zero is a trailing zero and is not considered significant. Here you have some examples. You can stop the video and you can study them. If you have any question after that, send me an email and ask me the reason of why I reported this number of significant figures. Well, the math in chemistry is known as dimensional analysis. Look at this. We know that every inch is 2.54 centimeters. This is a conversion factor. I know that 1 feet is 12 inches. This is another conversion factor. And 1 mile is 5,280 feet. In this case, I want to know the time in hours. And what is given? The distance and the speed of, in this case, of something that is moving from one space to another. The distance between 2 points is this. If you are going at a speed of 0.70 centimeter per second, then how many hours do you need? Well, you know the distance and you know the speed. Then what you do? You need to arrive to hour. How you can you do that? Well, first of all, I try to cancel miles by miles using this conversion factor. At this place, I have my answer in feet, but I need hours. Then I cancel feet with feet, and now my answer is in inches using this conversion factor. But I can cancel inches into with inches in order to get the answer in centimeters. And now I can cancel centimeters by centimeters, and my answer is in seconds. But still, I don't need seconds. I need my time in hours. So I know using this factor that 1 hour is 60 minutes. I cancel minutes with minutes. And now my answer will be in hour. This is the way you are supposed to set your data in order to arrive to the unit that I am asking for. You begin by what is given, and you arrive to what is asked. So, how do you solve this? First, you multiply 1 by 520 by 5080 by 12 by 2.54 by 1, and you get a number, and then you divide this by the result of the multiplication of 0.70 by 60 by 60. And then you get in the calculator this big number. Wow. But look at this. The given numbers have two significant figures and two significant figures. Phi 2, because this 0 is a trailing 0 and is not considered significant. And 0.70, this 0 is considered significant because you have the decimal point here. So how many numbers or significant figures you have to report in your answer? Only 2. Well, you can say, well, I will report 33, and then the 2, the 0, and the 8 will be considered zeros. And this can be an answer. Or you can convert this number into scientific notation. But in both cases, you have in your answer two significant figures. That is the number of significant figures in the given or knowns numbers. I know that this is new for you, but it's very important because from now on, you're going to have a lot of operations where you are going to use dimensional analysis. Well, in the quiz, some students didn't use dimensional analysis. They made the operation in steps different. What happened? That they made rounding ups in between, and then the final answer was not correct. That's why we cannot use other method in chemistry than dimensional analysis, because you cannot make rounding ups in between. You have to do the rounding up at the end in order not to make mistakes. I know that this part is difficult for you, so don't hesitate. Don't hesitate, sorry. Send me an email and ask me for more clarification. And we can meet by Zoom or WebEx, and I can explain you face to face. Well, that's all for today. Thank you and see you.